Okay, 4.3 I'd say is one of the longest notes that you're gonna have all year. So you might wanna watch part of it and then watch it, part of it another time. So the zeros of polynomials is called the title. You're supposed to find a degree 3 polynomial, and these are its roots. And it also goes through the point f of 3 equals a negative 24. This is a very time-consuming assignment. So if a negative 5 is an answer, you need an a out in front. If a negative 5 is an answer, you can do x plus 5. If 2 is an answer, x minus 2. And if 4 is an answer, it's x minus 4. They give you the point. This is the x and this is the y. So the y is a negative 24. And what we're doing is finding the a. So the x is 3, sorry. 3 minus 2 and 3 minus 4. Negative 24 equals a. 3 plus 5 is 8. 3 take away 2 is 1. And 3 take away 4 is a negative 1. Negative 24 equals a negative 8a. You're multiplying all four of those together. So a is equal to 3. Okay, now what you have to do is replace your a with 3 and multiply it all together. So this is what it's going to look like. Y equals 3. And remember that one solution was a negative 5. Another one was 2. And another one was 4. Now, I'm going to multiply these two together to get 3x plus 15. And I'm going to multiply these two together to get x squared minus 6x plus 8. And now, I'm going to multiply all of these together by taking the 3x and multiplying it by everything in the second one and 15 by all of them in the second one. And it's going to end up 3x to the third minus 3x to the second minus 66x plus 120. So the time-consuming part is multiplying all those terms together and then simplifying it. Okay, very similar. Again, degree 3, they give you the roots and they give you a point that goes through, but the only difference is you have imaginary roots. So you're going to put a y, you're going to put an a, you're put x minus 4 because 4 is a root, x plus 3i, and x minus 3i. Y equals a, x minus 4, and I'm going to put these two together, which will give us x squared minus 9i squared, because the middle terms will cancel each other out. So this is going to give us a x minus 4, x squared plus 9, because this equals a positive 9 if I squared is a negative 1. Now I can put the point in. The y is 50, and all my x's are a negative 1. You're going to get a negative 5, and you're going to get a 10 here. So 50 is going to equal a negative 50a. So a equals a negative 1. And now you have to go replace the a with the negative 1 here and multiply it all out. So distribute that, you get a negative x plus 4 times x squared plus 9, which gives you a negative x to the third plus 4x to the second minus 9x plus 36. Okay, the next one is similar, except when the coefficient is a, it makes it a little bit easier. You don't have to find the a. They're telling you that negative 5 is a root and 2 is a root, but you have 2 of each of them, the multiplicity of 2. So it's going to look like this. Y equals Negative 5 is a root, so you're going to put x plus 5 down twice because the multiplicity is 2, and 2 is a root. And you need 2 of them because the multiplicity is 2, which gives you x squared plus 10x plus 25. And here you're going to get x squared minus 4x plus 4. And your coefficient is 1, so you don't have to find the a. So y is going to equal, just to hurry this up, everything inside of the one parenthesis needs to be multiplied with everything inside of the other parenthesis. So you're going to have 9 terms, but then you can simplify it down to x to the 4th plus 6x to the 3rd minus 11x to the 2nd minus 60x plus 100. And then they're asking you also to sketch this one. Well, you know a negative 5 is one of the roots, and a positive 2 is another root. And you always look at the first term. If it's positive and even, your end behavior looks like this. Negative and even, your end terms look like this. Positive and odd, down and then up. Negative and odd, up and then down. So in this problem, it's even and it's positive, so they're going to both face up. And since there are 2 of them, they're going to bounce off, and since there's 2 of them, they're going to bounce off. Okay, the next one, again, you have to find a polynomial of degree 3. You know there are 2 answers here because it's bouncing. Do you see it's bouncing, and there's one answer here. So it's x minus 2 times another x minus 2 times only one x minus 4, and they put a y in front of it, equals y, and they give you a point on the graph, positive 1, negative 3. So y equals a, x squared minus 4x plus 4 times x minus 4. You know that the y is a negative 3, and the x is 1. Which gives you negative 3 equals a. 1 minus 4 is a negative 3, and a negative 3 plus 4 is 1, and that's going to make a negative 3, which gives you a equals 1 for this problem. All you have to do is multiply this together, the circled part, for your final answer. And to hurry this up, it's going to be x to the 3rd minus 8x to the 2nd plus 20x minus 16. Okay, this part, it's already in factored form, and they want you to come up with the zeros or the answers or where it crosses the x-axis. This is to the first power, so you're going to have 1 there, you're going to have 4 zeros here, and 6 zeros here. So you set this one equal to 0, you set x plus 1 equal to 0, and you set 3x minus 7 equal to 0. X equals 7/3, x equals a negative 1, and x equals 0. But how many negative 1s? There are 4 of them. And how many 7/3? There are 6 of them, because you need 11 zeros for this problem. Number 5 is factored for you. Number 6, you have to factor it. 2 sets of parentheses. You're going to put an x here and an x squared here, both x squared, positive 25 and a negative 4. That will give you 21 in the middle. You're going to have 2 answers here and 2 answers here. X squared plus 25 equals 0. X squared minus 4 equals 0. X squared equals 4. X squared equals a negative 25. Square root, square root, square root, square root. X equals plus or minus 2. X equals plus or minus 5 I. Okay, we got a lot of notes to go. So, given the polynomial and the 0 equals 4 with a multiplicity of 2, find the factored form of this polynomial. Well, they're giving you 4 and they're telling you that there's 2 of them. And they want this in factored form. So what I would do is I would do synthetic division, and I know that 4 is one of these solutions. I'm going to put a 1 for the coefficient, then a -9, then a +22. Remember, it's missing a power, so it needs a 0 and a -32. Draw my line. I already know that this should turn out to be a 0 right here, because they're telling me that 4 is 2 solutions. I start this process by bringing down my 1, a 4, a -5, a -20, a +2, a +8, a +8, and a +32. I also know that there are 2 of them, so I'm going to do it again. I know that there are 2 4s. Again, after the 8, it should turn out to be 0. Start my process by bringing down my 1. This is 4, -1, -4, -2, and -8. Okay, so they want this in factored form, and you know it's 4 of them. So you know that x minus 4 is 1 and x minus 4 is 1. And the other 2 are hiding right here. X squared minus x minus 2. So y equals x minus 4, x minus 4, and x minus 2, and x plus 1. Because that's how you factor that. Okay, the next one is on the test, so I need to go over how to do it. So basically, this is the polynomial of degree 3. So you need 3 parentheses in factored form, but it's missing one of them. It's missing the a, but you know 2 of the answers. One is x equals 1, and the other one is x equals a -4. So I'm going to come down here and do synthetic division. And I know I'm going to get 0 here, but they're already telling me that 1 is one of the solutions. And I already know that -4 is the second solution. Bring down my 2 to start this. -8, +1, -4. So, in factored form, I know that 1 is a solution. I know that -4 is a solution. And I know the rest of it's right here, which is 2x plus 1. So, doesn't this right here look like this? So, doesn't a equal a +1? And you are done. Okay, this next part is really weird, and it goes on to the next part, but Descartes was a famous mathematician who could predict the roots to a polynomial without solving it. And he makes a penny chart. So, you know that there are 3 answers to this problem because it's degree 3. What Descartes does is he predicts what kind of an answer it's going to be. And this is kind of confusing, so you might have to watch this part over again. But what you're going to do is you're going to do f of x is 5x to the third plus 6x minus 4. And then what you're going to do is you're going to replace the x with a negative x, which makes a negative 5x to the third, a negative 6x, and a negative 4. So I'm going to circle this one, and I'm going to circle this one. So this one and this one. This one is going to go here for the positive, and this one right here is going to go for the negative. And what you do is you count the change in signs. So this is the first term, and the first term's positive. And my second term is also positive, and my third term is negative. So it changed only one time with 5x to the third plus 6x minus 4. Now you're going to count the change in signs for this one. Well, it starts off negative. The second term is also negative, and the third term is negative. Do you see that it doesn't change from positive to negative or negative to positive? So that's going to be 0. Okay, so that's how you get the positives and the negatives. How do you know the imaginary answers? Well, you know the degree is 3. If there's one positive root and no negative roots, there has to be 2 imaginary roots, because this whole thing needs to add up to the highest degree. So without even solving this problem, Descartes predicts, very, very smart mathematician, he predicts that if I solve this problem, I'm going to have 1 positive answer and 2 imaginary answers without even solving the problem. Okay, let's do another one. So Descartes says that there are 4 solutions to this problem. This is the original problem. This is going to be the change in signs of the positive. So it starts with a positive x to the 4th, then it goes a negative 9x to the 3rd, then a positive 22x to the 2nd, then a negative. So when I go from, let's get rid of this little negative right here. When I went from a positive to a negative, I changed once, negative to positive twice, positive to negative 3 times. So this needs to be a 3. And I'm not going to put that down right there. I'm going to put it right here for now. This is where it gets a little confusing. Okay, this one, I put a negative x in for all of the x's. When I put a negative x in, that's going to end up being a positive. If I put a negative, that ends up being positive. When I put a negative, it ends up being positive, and you can't plug a negative in there, that ends up staying. I went from a positive to a positive, no change. A positive to a positive, no change. A positive to a negative, 1 change. The negative changes is equal to 1. Okay, now this is what comes weird. Descartes says that you can deduct by 2s. So this could be 3 or 1. Positive changes. Negative, you can't go, you can't have a negative amount. And then I'll come back to show you how to make a penny chart in a minute. Okay, let's do one more. Okay, so let's go back. How many ways can you get dressed in the morning? You can have the striped shirt with the pants, or the striped shirt with the blue pants. So the striped shirt with the red pants, or the striped shirt with the blue pants, the polka dotted shirt with the red pants, and the polka dotted shirt with the blue pants. There are 4 ways to get ready, and that's very similar to what we're going to do here. Pretend that these numbers are the shirts, and this is the pants. The 3 can go with the pants, and the 1 shirt can go with the pants. Do you see that there are 2 ways that you can make a PNI chart? Because the shirts, you have 2 options, and the negatives, you have 1. And you know you have 4, so this has to be 0. This needs to be 2, because this needs to add up to 4, and this one needs to add up to 4. Okay, let's do another one. We have 2 more. Hopefully you'll catch on. This is f of x. And this is what happens when you plug a negative x in for all the x's. When you plug a negative x in here, it stays positive. It goes from a negative to a positive. It stays positive, positive. It goes from a negative to a positive. and a positive to a positive. Okay, now once you change yours, now you're going to sit and count your positive changes. From positive to negative is 1 change, negative to positive is 2, positive to negative is 3, negative to positive is 4. There are 4, or you can always decrease by 2, 2, or 0. Those are the 3 different, until you get down to either 0 or 1. The negatives, nothing. It goes from positive to positive, positive to positive, positive to positive, positive to positive. There are 0 changes. Remember that these are your shirts. You have 3 shirts, and you have 1 pair of pants. So the shirt can go with the pants, the shirt can go with the pants, or the shirt can go with the pants. You know the highest degree is 4, so this has to be 0 because this has to add up to 4, this has to add up to 4, and this has to add up to 4. One of those 3 choices is right, is what Descartes says. He's predicting one of those 3 options is right for the 4 answers. There could be 4 positive answers, there could be 2 positives and 2 imaginaries, or there could be all imaginaries. This is called Descartes. Last one. The highest degree is 9. I just made up this. The power is 9, so x to the 9th is your highest power, so there could be 9 answers. When you count the change in signs for positives, there's going to be 4, or 2, or 0, and these stands for your shirts. 3 or 1 will stand for your pants. So if you have 3 shirts and 2 pants, there are 6 ways you can get ready. You can put the 4 with the 3, or you can do the 4 with the other pants, which is a 1. You can do the 2, which is a shirt, with the 3, or a 2 with the 1. Or you can do the 0 shirt with the 3, and the 0 shirt with the 1. And remember, there's 9 answers, so this needs to be 2, this needs to be 4, this needs to be 4, this needs to be 6, this needs to be 6, and this needs to be 8, because there's 9 answers. So all of these have to add up to 9. And I'm going to try to explain to you why you always decrease by 2. See how we decrease by 2? If you always decrease by 2, imaginary numbers will always be even because they come in conjugate pairs. So maybe you understand why we have to decrease by 2. See how they always come in pairs? That's why the imaginary numbers always have to be even. So okay, the assignment is done.